Hello everyone. In this video, we will learn about how to identify the heap problem or how to identify that the problem is asking the heap implementation, right? And after that, we will also learn one problem, right, which is very standard, which is kth largest element. So like how to identify that we have to use heap in the problem, right? So one thing which could be seen in the problem statement is that by sorting the data structure or by sorting the container or the array, whatever which is given to us, the answer can be made, right? Like by simply sorting it, answer could be made, right? It would be difficult for understand in the starting, but it will take time to digest. And once we will reach to the problem, you will able to understand and digest what I'm saying. But just for now, just take it as a grain of salt. So by sorting it, our problem would be solved. But again, like by sorting it, our time complexity will reach to n log n, right? And pretty much it would not be sufficient to pass all the test cases. After this is one identification part. Is another identification part would be the element, or the question would be asking about maximizing stuff, or largest element or smallest element, and all those stuff, right? So this is the second point which I consider while solving the heap problems. Sometimes we get confused with the DP, because DP problems are also for the maximization and minimization. But the heap or the problem will specifically show some greediness itself, right? So don't just simply go to DP directly. Just first think greedily, and after that, okay, if you are having some test cases that okay, that greedy approach will not work, then move to DP, right? So yeah, this identification element would be there, and then we need to reduce the time complexity from n log n to n log k. So these are some identification things which I believe will help out while solving the heap problems. And one approach I or one identification which I believe is basically that there are some k type keywords available, right? So those will be helpful by identifying that okay, the problem is for heaps. So these are small 2 to 3 elements which I believe helping out the heap problems, or to identify the heap that I have to use the heap inside. Okay, now let's move to the problem statement. So the problem statement is very standard, right? So which is the kth largest element, and let's understand the problem first. So we have been given an array, right? It contains some integer elements, and then k also we have given. So we need to find what is the kth largest element, right, in the array. So without any thinking, right, without any thinking, you would say to me that okay, so no, what we can do is we can just simply sort this array, right? By sorting it, what it would become, 2 4 5 8, right? It becomes like that. And after that, I'll say okay, 3 minus 1, which is 2, right? So you will give this index and this value, that's so no, hey, this 5 is the kth largest element in the array. Great, right? This completely for this approach completely works and gave us the time complexity of n log n, right? So this will not be enough to solve this approach would not be enough to solve all the test cases, because it will give time limit exceeded for some test cases, though I'm not sure, I didn't try, but I believe what it will happen, right? So yeah, we can see that identification elements are there, kth largest, and sorting is basically able to solve our problem. So I think we can use heaps or priority queues in here, right? Now you will say that okay, we believe that we have to use heaps or priority queues, but what type, right? Like should we use heaps, or should we use max heap, or should we use min heap, right? So I would say that if anywhere somebody is asking about increasing or larger element or the increasing part, then you can try with min heap, right? Though I'm not saying 100% that it will work, but it will work for more than 60%, right? So if so in question, if it's something is asking about maximizing or the largest or the toppest or the biggest, right, then you can try with the thought of min heap. But I'm not saying that it will work always 100%. More than 60% definitely I can say that it will work, but I cannot guarantee it about 100%. And opposite of this is same, like if something is asking about decreasing the stuff, then I can use maxi. Again, the same percentage I would like to go for them, right? So these are some these are some my approach which I would believe while solving the heap problem, and like which heap should we use, right? So okay, fine, we also understand that. Now what? Now you said that okay, large is there, so it's asking some increasing stuff, then I should use min heap. Fine, I should use min heap, right? Now okay, even if I use min heap and I'll store all the elements, then the time complexity will not be, greatest. What I mean by that is, if let's suppose I store all the elements in the heap, right? So okay, you will say for uh, like I cannot define properly, but for min heap it would become something like this: 2 4 5, and oh, I believe this one would be 8, right? In this way min heap would be there inside the container, though I'm not 100% sure how internally it would be. Like 5 would be here, it would be here as well, but it would be anyhow complete binary tree, the structure would be the same. Correct. Now if I'll make that from this array, then time complexity without heapify, the time complexity would be approximately n log n, because for you're iterating for n elements, and then you are also making a tree with the depth of log n. So anyhow the time complexity becomes like that. So can we do anything better? So yeah, what we can do is we can just create the depth of the tree by log of k only. We don't need to just stretch it by log of n, right? And why would I say that? Let's see. So let's suppose an element came, right, which is 4. So you store it in the container or inside CBT, right? So uh, don't believe it as a vector or something. Just understand that inside it is a tree. So and then after that 5 came, but 5 will not be at the top. 5 would be at the bottom because it is the min heap, and 4 would be here. 5 came, and then 8 comes. Then again this would become something like this: 8, 5, and 4. Right? And then you would say that okay, Sonu, the size is 3 now, so stop it. I will not increase the size of it. Now what I will do next is that okay, 2 came, right? So I will check the top, that if my toppest element, right, if my toppest element is lesser, right, if my toppest element is lesser than the coming element, which is 2, right, if 2 is greater, because see, my focus is to get the largest element. That's why I'm checking that if the element which is coming is greatest or not. If this is smallest, then what I want, I don't want anything, right? But if this is greater, then it will help us, right? It will definitely gonna help us. So that's why I'm checking that if this is the greater, then simply just add it and remove the top, right? So that is the basic approach which we will use to solve this problem. I know it would be difficult to digest in the first go, but once you will go to the actual code implementation which I have wrote, then you guys will understand. Okay, so again, now I'll just give one more example, which is like 1 5 7 and 3. So initially 1 will come, right? And the k, let's suppose k is 2. So 1 came, and then 5 will come, right? Now the 7 is there, right? And anyhow we are using min heap, right? So 7 is there. So 7 came, and then you will say that okay, the size is 2. Now I cannot simply add it, right? Because before making the size 3, if the size is not 2, let's say, for this particular example, I'll simply append it in the priority queue. I'll simply add it, right? But if the size is 2, then I cannot increase it, because my time complexity will or my the depth of the tree would reach to n, and I don't want that. I just simply wanted k, right? So anyhow the 7 came, and then you find out that top, right, top of the heap, is it lesser than 7? Because my motive is to get the seventh my motive is to get the largest element in the heap only. That's why I'm using min heap, so that my all minimum elements or small elements would remove from the top, and if something larger is there, I will simply store it. That's my main motive, right? And then it would okay, so I will insert 7 inside the heap and remove the top element, which will be definitely smaller. So then my heap will become 5 and 7. and 7 is removed, and then it will come 3, and I'll check with top element that okay 3 is greater, no, then simply just it, and then I'll say okay 5 is the uh, like 5 is the second largest element, right, in the array. So that's all about the approach what I was saying. Let's go to lead code, and the problem is slightly different, that the stream is coming, right, and we need to find the kth largest element every time, but the concept would be similar, right. Now what I mean by that is that initially what I did, I just defined a min heap, right. You can see that I defined a min heap. After that I just taking the some class variable so that I can store it. After that, this is the constructor which is provided to us. And then initially, see what I did, uh, I just stored all the elements till kth size, right. uh, I added this condition to handle the test case, because if n is smaller, so it would go out of bounds, so that's why. So I just store all the elements till the k. Once I stored, I will just iterate it for the rest of the elements, right. That if we understand, right, the part is like that we don't want our tree to increase the size by log n, right. So that's why I just want to take it till log k, correct. So that's why I did that. And after that, okay, let's move next. So after that, I did, I just if my element is greater, right. So if 5 is less than 3, if the element which comes new is greater, then I'll simply pop the existing one and push the one which is the greater, right. And like this is simply the while loop which you guys might understand, right. After that, this is the constructor I did for the starting point, right, because I got the array and I also need to put k across it. So I'll store the k also in my global k, and store all the heaps element, or all the elements which I want in my priority queue, or the min heaps. At the end, now I have to implement the add method. So the value will be coming, and then I need to just return the top kth element, right. So the stream would be coming. And now what will happen is that I just need to check the size, right. As I said, if my size is lesser, then I'll simply push it, I don't need to worry, right, because anyhow I can make the depth till k. I'm not increasing the depth by more than k, so it's okay, I can do that. After that, I will say that okay, if the element is greater, right, so I simply just push the value and just pop the current one, right, because anyways I did that, because you guys will find it confusing. You will say, hey Sonu, you did that, and now here you are just simply pushing and popping it, right. Because anyway, let's suppose 5 3 is there, right. So in min heap the structure is like this, 3 and 5, and let's suppose 2 came, right. So even if I'll just add 2 in the min heap, it would become something like this, right. I just push it and I'll just simply pop it, right. So over there it was something not like that. I was just first checking it. In here I'm simply pushing it. So I just first push the value and make the CBT like this. After that I popped it. So popping will be anyhow will be just removing the top element, which is the smallest one. So 2 will be removed, and 3 and 5 structure will be the same. So that's how it will go, and it will all work. And I hope I try to explain small crux about this problem and all. uh, Although I'm learning more about it, and I'm also learning by teaching. And so that's it, it's all about for this video. I hope you got something, and I hope you learned something from this video. And if that, so thank you so much for this, thank you so much for watching.